Okay, let's see the next question. So this is the result of this experiment to find out how the surface area of a parachute affect the time taken to run 50 meters. So the time to complete, you can see as the surface area of parachute increases, right? The time taken to complete 50 meters also increase. So based on the information, what is the relationship between the surface area of the parachute and the time taken to complete 50 meters run? So this is very straightforward. You can just mention this part. The greater the surface area of the parachute, the longer the time to take to complete 50 meters. Okay, next, if you cut a few holes in this 1,300 square centimeters parachute, right, will be more than, equal, or less than 16 seconds. So answer will be less than. Okay, you need to explain this clearly. Because with holes, all right, you have less surface area, and this will result in lesser air resistance acting on it. Okay? Because you got holes, right? So this part, right? Let's say if I draw holes here, right? Let's say there's holes here. Okay, there are holes in the parachute, right? So the wind can go through the hole. Okay? As a person run forward, right? The wind will go through the hole. Okay? So this will result in lesser air resistance. Okay? Lesser air resistance, and allow the person to complete the same distance of 50 meters in lesser time. Okay, so I will screenshot this and send to you shortly. Let me pause this for a while. Okay, let's look at this question. This is a device to take photographs of wild animals if they land on point X. So if there's a weight here, right, it will cause the spring to compress. Okay, as the spring compress, right, these two contacts will touch each other and will form a closed circuit. And we'll turn on the battery-operated camera to snap shots of the animals there. So you're supposed to explain how this setup take photographs of wild animals when they land on point X. So this integrates the topic of electricity and forces. So this is how you answer. When the animal lands on point X, it lands here, right? So you must say it compresses the spring. It compresses the spring and cause P and Q, right, to make contact or to touch each other, resulting in the closed circuit. The camera is able to take a photograph of the wild animal. Okay, closed circuit. Then part B. Part B. Okay, now part B is a graph interpretation. So do take note. There are some students, when they look at graphs, right, they a bit panic. So not to panic, this is skills in graphical interpretation. Take note of the two axes. Understand what it means. So this is on the horizontal axis. It shows the mass. So as it increases from 10, 20, 30, 40, up to 70, right? And then this is the length of spring. Okay, take note in this setup, right? The greater the mass, the shorter the spring, because it's being compressed. So you must understand this logically. Okay, you must understand logically. So all started with the same length of 80 centimeters. So which is the most elastic? So you must identify C is the most elastic. Why? Because for the same mass, right, spring C being compressed the most. Okay, so you must understand this. So once you understand that spring C is the most elastic, it's good to annotate here, most elastic. Okay, most elastic. So explain which spring should you use in order to take photographs of small animals. So small animals will be lesser mass, right? So lesser mass, I must use a spring that's most elastic. So that's spring C. So by annotating here, it actually facilitates your answering here. So the complete answer with this, okay, spring C is the most elastic. Why? Because it compresses the most. So similarly, use a superlative to describe. Compresses the most. When the same mass was added. So it means lesser weight is needed for point P and Q to make contact. So P and Q refers to the diagram here. Okay, so you must answer in this manner. Then you will get the 2 marks. So identify the spring, explain why. Why is it most elastic? Because for the same mass, it compresses the most. So when the animal of smaller mass, right, it will be able to make point P and Q to touch each other. So the photograph can be taken. Okay, then the next part, right? It says that this student observed that when small animals land on point X, no photograph of the small animals were taken, even though the camera was working properly. So here they say, besides changing the spring, suggest one change that she can make to the setup so that the camera can take photograph of small animals. So by examining this setup, right, there are a few things you can do. If I erase this part, right, you can actually increase the surface area of P and Q, the contact, so that they are nearer to each other. Or you can shift P and Q towards the pivot point. Okay, where's the pivot point? The pivot point is this part. Okay, shift them closer to the pivot point. So these are the possible answers. Move the two contacts closer, okay, or you decrease the height of the contact point P and Q so that the contact is closer. Okay, or you can increase the surface area of the two contact. Okay, as I said, decrease the height of the contact point means this part. Make it nearer to here. Okay, shift them nearer. Okay, decrease the height or increase the surface area. So these are the possible answers for this question. Question 6, which is this diagram on the extension, or this is compression mass graph. Okay, mass and compression. Okay, later we do on surface area, so you take note of this question and how to answer them well. And then we'll proceed to the next question soon. Okay, next question. Two identical pieces of paper. One is a flat sheet, one is being crumpled, and they are being dropped at the same height. Okay, and the time taken is being timed to see how long they take to reach the ground. So we understand that the flat one, right, the flat sheet take a longer time. If you compare the 3 timings here, right, 3 tries, right, so all the 3 tries exceed the timing for the crumpled piece of paper. So state the forces acting on this. So there are 2 forces. One is going down, gravity. The other one is the upward force, the air resistance. Okay. So it's a frictional force, which, or you can say the air resistance, and secondly, the gravitational force. So each correct answering will give you half mark. Frictional force and gravitational force. Okay, why did the crumpled ball reach the ground first in all the 3 tries? So you look here, the specific scientific explanation, you must mention that number 1, because crumpled ball, right, or paper has what? Lesser contact area or lesser surface area in contact with the air than the flat sheet of paper. Okay, this will result in lesser frictional force. Okay, lesser frictional force between the crumpled ball and the air. So this is how you explain these 2 parts. Okay, so this explanation for these 2 questions. Okay, I will stop here and allow you to ask questions. Okay, let's see question 8. Okay, Ziwen tried to push 2 identical boxes, F and G. F here, G here. And box S is filled with 10 kilogram rice. G also 10 kilograms of sand. So both of same mass but different material. But there are wheels on box G. So Zhiwen found that he uses less effort to push G. Explain why this is so. So you must explain the presence of wheel, right? Reduce the frictional force. Okay. So you say the wheels under box G reduce the friction or reduce the frictional force between. Okay, this word is very important. Frictional force always between the box G and the ground. So it was easier for Zhiwen to push box G. So this is the first part of the answer, where I would screen share to the student for them to do their self-checking. Next, part B. Explain why Zhiwen still conduct a fair test even they use different materials. So as I mentioned earlier, one is rice, right? The other is sand. Because the material doesn't affect this experiment. It's the mass. So you must answer in this manner. Despite different materials, the mass of the boxes are the same. Because friction is only affected by the mass and the roughness of the surface. Roughness of the surface means like the floor. Okay? It's not affected by the material. So this is the part you need to mention, that frictional force is affected by the mass, not the material of the box. Okay, everyone? Good. Let's continue the next part. Okay, this is a device. How does this work? So if you inflate the balloon, right, when you release the balloon, the air will be forced out here. So there's a force, a pushing action. The balloon and the wheels will go to the right-hand side. So they ask you to draw an arrow in the box to indicate the direction which the toy would most likely move when air is released. So you should indicate with this arrow. Okay, so in the written answer, you can draw a straight line using a pencil for pushing forward this way. Okay, next. Okay, there's a part number 9. We'll do it later. So we would stop here for a short break.